Hello girls, in this video you are going to have a revision on 3D shapes. The learning objectives in this chapter is to recognize the properties of cones, pyramids, cylinders, prisms, and spheres, and to make the nests of cuboids and cubes. Do you still remember the names of these 3D shapes? We have learned prisms, pyramids, cones, spheres, cylinders, and for prisms, there are two bases with same shape and same size. For pyramid, there is only one base and with a pointed top. For cone, sphere, and cylinder, there are some curved surfaces. Next, still remember we have talked about the vertices, edges, and faces of 3D shapes? When you look at these pictures, this 3D shapes is made up of some sticks and plasticine balls. For the sticks, in the math terms, we will use edges. For the plasticine balls, we will use the mathematical terms vertices. And each surface of a 3D shape is called a face. The line where two faces meet is called an edge. The point where three or more edges meet is called a vertex. Now let's look at the vertices and edges of these 3D shapes. For the first one, it is a triangular prism. We can see that we make use of 6 plasticine balls. 1, 2, 3 at the bottom, 4, 5, 6 on top. And the number of vertices will be 6. For the number of sticks, we can see that we have 1, 2, 3 sticks at the bottom, 4, 5, 6 on top, and in the middle we have another 3, 7, 8, 9. So in total there are 6 sticks. That means there are 9 edges. And look at the last column. You are asked to find the number of sides of the base. So for the base, we have 1, 2, 3 sides as it is a triangle. Why do we need to find the number of sides of the base? Actually, there are some relationships between the number of sides of the base and the number of edges and vertices. Let's look at rectangular prism. Maybe we can find out this relationship. So for rectangular prism, the number of plasticine balls is, so at the bottom we have 1, 2, 3, 4. On top we have another 4, 5, 6, 7, 8. So we have 8. And then for the sticks, at the bottom we have 1, 2, 3, 4. On top we have another 4. In the middle we have another 4. So 4 times 3, we have 12 sticks. That means the number of edges is 4. And the number of sides of the base, as it is a rectangle, so we have 4. For the last one, pentagonal prisms, for the number of plasticine balls, at the bottom we have 5 here, and then on top we have another 5. So that's why we have 10 balls. That means there are 10 vertices. For the number of sticks, we have 5 at the bottom, and then 5 on top, and then another 5 in the middle. So we have 5 times 3, we have 15 sticks. That means the number of edges is 15. So now let's look at the table. Can we see any relationships? Let's look at the number of sides of the base and the number of vertices first. So maybe number of sides of the base and number of vertices. 3 and 6, 4 and 8, 5 and 10. Yes, the number of vertices is 2 times of the numbers of the sides of the base. What about number of sides of the base and number of edges? 3 and 9, 4 and 12, 5 and 15. Yes, the number of edges is 3 times the numbers of sides of the base. What about in pyramids? Let's do it similarly once again. So for triangular pyramid, we have 4 vertices, 1, 2, 3 at the bottom, and 1 pointed top, so totally 4. For the edges, at the bottom we have 1, 2, 3, 3 at the bottom, and then 4, 5, 6 edges. And the number of sides of the base, as it is a triangle, so it is 3. For rectangular pyramid, for the vertices, 1, 2, 3, 4 at the bottom and plus 1 on top, the pointed top, so we have 5. And the number of edges, we have 4 at the bottom, another 4 on top, so we have 8. And the number of sides of the base will be 4. And the last one, pentagonal pyramid. For pentagonal pyramid, the number of vertices, we have 5 here, plus 1, so it is 6. Number of edges, we have 5 at the bottom and 5 on top, so totally 10. And the number of sides of the base, as it is a pentagon, so it is 5. So now let's look at the relationship. Number of sides of the base and the vertices. So 3 and 4, another pair, 4 and 5, last pair, 5 and 6. So we can see that the number of sides of the base plus 1 will be equal to the number of the vertices. What about number of sides of the base and the edges? One is 3 and 6, the second pair 4 and 8, the last pair 5 and 10. Yes, the number of edges is actually 2 times of the number of sides of the base. So I have summarized the relationships in this table. So you can see that for prism, the number of sides of the base and the number of vertices, they are 2 times. And the number of edges is 3 times of the number of sides of the base. And for the number of faces, it is n plus 2. For pyramid, we have another relationship. Let's try to use this table to find the number of vertices, edges, and faces. So it is a triangular prism. That means n is 3. So 2n will be 2 plus 3, that is 6. 3n is 3 times 3, that is 9. n plus 2, that means 3 plus 2, that is 5. So we can see that you can get the answer easily. Let's try triangular pyramid. Again, the number of sides of the base is 3. Number of vertices will be 3 plus 1, that is 4. Number of edges, 2 times 3, that is 6. And the number of faces, n plus 1, that means 4. So you have 2 ways to find the number of vertices, edges, and faces. The first one, you can make use of this table. The second way is you count it one by one from the picture. You count it one by one from the picture. Let's look at some more examples of 3D shapes. In this question, which 3D shape can be made using the plaster symbols and sticks below? So for the sticks, there are 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 sticks and 6 balls. Can we make triangular prism? How many sticks are there in triangular prism? In triangular prism, if you count it one by one, 3 at the bottom, 3 on top, and then 3 in the middle. So we need 9 sticks. And for the plaster symbols, 3 at the bottom, 3 on top. So we need 6. So we can make triangular prism. What about rectangular prism? So look at its base shape. It is a rectangle. So we have 2 bases. So we have 4 here, another 4, and then 4 in the middle. So that means 12 in total. So we don't have enough sticks to make rectangular prism. What about pentagonal prism? We know that we need more sticks to make pentagonal prism than rectangular prism, so it must not be the answer. What about pentagonal pyramid? Pentagonal pyramid, the base is a pentagon, 5 sticks. And then we have another 5 sticks on top. So we need 10 sticks. So we can't make pentagonal prism, a pyramid. So the answer is triangular prism. Yes. Next one. Billy wants to use the plaster symbols and sticks below to make a hexagonal pyramid. How many more plaster symbols and sticks are needed? So this time we are going to make hexagonal pyramid, and we need to consider how many more, okay, more boards and sticks are needed. For hexagonal pyramid, the base shape is a hexagon, right, with 6 sides. So for the number of sticks, it is 2 times of the base, the size of number of sides of the base shapes. So we need 12 sticks, or you can count it from the picture. We have 6 at the bottom. This is the pointed top. We have another 6 on top, so we need 12 sticks. For the number of balls, the relationship is, still remember, n plus 1. So it is 6 plus 1. We need 7 balls. Or you can count from the picture, because we have 6 for the base, 1, 2, 3, 4, 5, 6, and 1 pointed top plus 1. So we need 7 balls. So at first, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 sticks. And 5 balls. So how many more are needed? For the balls, 5 and 7, that means we need 2 more. For the sticks, 11 and 12, that means 1 more stick. Okay? This is another kind of question. A prism has 10 vertices. What is it? So think about the relations between the number of base sides and vertices. It is 2 times relationship. So it should be a pentagon. 10 divided by 2 is 5. Or you can draw it out. So the base is a pentagon. We have 1, 2, 3, 4, 5. At the bottom, 5 vertices. And for the top, for the top base, 1, 2, 3, 4, 5. We have another 5. This. So there are 10 vertices. Okay? And second question, how many edges does it have? As we know that the base is a pentagon, that means there are 5 sides. For the edges, it is 3 times the number of sides of the base shapes. So it is 5 times 3, it is 15. 15, 5 times 3 equals 15. Or you can count it one by one. So at the bottom we have 5 edges, and on top we have another 5, and then in the middle we have another 5 edges. So again, 5, 5, 5. We got 15. Okay? Next part, we are going to talk about the nets. This is the nets of cubeball. How many faces are there in the net? You can see 1, 2, 3, 4, 5, 6. And for each face, it is a, what shape is it? Yes, it is a rectangle. So which of the nets below can be folded into cuboids? So in this case, we need to think about the adjacent sides. Are they of equal length? Can they be attached? For example, picture 1. I can see that these adjacent sides, they can be attached because they are with equal length. This is the first pair, and this is the second pair, third pair, the fourth one, the fifth one, and the sixth one. So all of them can be attached. So it can be folded into a keyboard. What about picture 2? Can you find out some adjacent sides that are not equal in length? I think you got this pair, maybe. So these adjacent sides are with different length, so that it cannot be attached. So that's why we cannot make a keyboard. What about picture 3? After checking, the adjacent sides are with the same length, all the adjacent sides. Like this 1, 2, I don't show you all. So here, number 3, we can make it. What about picture 4? Look at the adjacent sides. So I know you can figure out this pair, different lengths. So no, for this case. What about picture 5? So this is first pair, same length. And then second pair. And the third one, well, etc. So after checking all, it could be made a keyboard. What about the last one? You may try by yourself. You should find that all the adjacent sides are with equal length. So, like this, okay? Now, next part is about the nets of cubes. For cubes, they are made up of 6 squares. For the nets of the cubes, they are made up of 6 squares. And you can see that there are many different kinds of shapes making up by 6 squares. Some of them can be folded into cubes, but some cannot. Yes, for the green one, only the green one, the combination of the green pictures can be folded into cubes. So let's see. The first case, if I put all the 6 squares in a straight line like this, obviously you are missing some base, the base and the top. So obviously it cannot be folded into cubes. And if we line them up in 5 squares, 5 squares here, 5 squares here, 5 squares here, again, you cannot make a cube. So if you see the net with 5 squares putting together in a straight line, it cannot be folded into a cube. And then if I put it like this, with 4 squares putting together, 4 square putting together, and the other 2 square is in one side, That means 4 here, and then the remaining, both of the two is in the same side. Okay, so 4 in a straight line, and then the remaining 2 is in the same side. In that case, you are missing either a top or a base, so we cannot make it. And then the next row, we put it in line of 4 squares in a line, like this, 4 square, 4 square. Okay, and then the remaining two, one is here, one is here. They are in opposite side. Okay, not in at the same size. Then it could be, we can make a cube. Okay, and for some pictures, if you can see that there's 4 putting together, like the Chinese word 田啊，一個田字。Okay, when you see this, you can never fold them up. Okay, like this case. All these cases, we cannot fold it up, so we cannot make a cube. Okay. So we have eliminated some possibilities. Of course, some of them you need your imagination. If you really are not sure which one can be folded into a cube, you can cut it out and fold it and try it. That means try it out, cut it out by yourself. So in total, there should be 11. Okay, 11 possible combination. 11. Okay, 11 nets of the cubes. So now look at the nets of these cubes. There are some pictures on the cubes, and you have to find out which cubes are folded from the net. So first you can check the position. The first cube, we have the dog, the turtles, and the cat. So they are next to each other, so it seems to be correct. The second thing you have to check is orientation. So that means the ear of the dog, is it pointing to the tail of the turtles? No. So this is wrong. And then let's see picture 2. Picture 2, we have the rabbit, the cat, and the dog. Again, they are packing next to each other. So now check the orientation of the cartoons, the pictures. And the ear of the rabbit is to the cat. Yes. And the ear of the dog is to the face of the rabbit. Yes. And the ear of the cat is to the face of the dog. So it is correct. Last picture. The 3 animals are dogs, cats, and rabbit. Yes, they are next to each other. And then look at its orientation. So cat's ear is pointing to the dog's one, but here the cat's ear is pointing to the face of the dogs. So that is wrong. So in this case, first we have to look at the position, and then we look at the orientation of the pictures inside. So that's all I want to share in this video. Hope it is useful for you. Thank you. Bye bye.